So good morning, good afternoon. Today we are speaking about two new types of logs. We are talking about the tracer logs, a new way of logging to join the volumetric analysis of fracture in geothermal reservoir. So for geothermal reservoir we have a specific characterization of this, and the tracer log offers the possibility to test and involve injection and the touchable substance like chemical, radioactivity, thermal or fluorescence traced into the geothermal wells and monitoring its arrivals in one or more observation wells or production strings. Its type is that it's clear that this kind of logs have several purposes. The primary goal and purpose of log tracers in geothermal wells are to characterize the geothermal reservoir, create detailed models of reservoir behavior, identify flow path, like for example fault zone, fracture, and estimate reservoir volume and heat exchange in surface, and surface heat exchange. That is very important to planning the subsurface operation to capture the heat from the earth. Optimize production and injection, determine the connectivity. So the second purpose is to optimize, as you just said, the production and the injection, determine the connectivity between the injection and the production wells, the well pair connection, assist the efficiency of fluid circulation, and help design optimal injection strategies. Predicted geothermal breakthrough. A critical application is predicted when cooler injection water will reach the production well and the cause of the temperature. The monitoring well integrated. Also another function is very important for the tracer log is monitoring well integrated, detect flow irregularities such as potential leaks, casing failure, quantitative flow. So modern techniques like tracer flow testing, the TFT as called, we can be used for quantitative production logging in alternative to PLT, providing a real-time single data and two-phase mass flow rates, and also estimate the enthalpy, how we can change the enthalpy in the reservoir. So it's clear the main goals of object is identify the flow channels and the fracture connectivity. We can also build up a model of fracture connectivity and how it works from a hydraulic point of view. Quantify the flow partitioning among fracture, estimated the effective reservoir volume, and attach the dead and the fracture with no flow through. It's clear that, for example, there is some specific geological condition with some fracture we can be empty by like some sediments or resediments like this. Determine the fracture stripe and the deep direction based on trace plumb movement. So this is some of the best purpose. We can also have a list of methodology. A typical trace test involves injection, monitoring and sampling. We are sampling, for example, with fluid are sampling and collected over the time from production wells, air monitoring points, and analyzed for tracer concentration and temperature. What type of tracer we can be used? Tracer used in geothermal application must be stable in high temperature and high pressure, it's clear. And we can use chemical trace like fluorescence dyeing, radioactive trace using specific logging technique to measure fluid velocity down the well bore. So the velocity shot and detect fluid loss into the formation. Gas tracker like krypton is used to steam gas phase. The novel trace recent developed include thermosensitivity tracer that exchange property based on temperature, and biotracer like composite materials that can be used to like a new type of casing. And so the tracer testing is multiple application in geothermal research and management. The main purpose in conventional geothermal developing is to study clear the connection between the inaction and the production borehole as part of re-inaction research and management. Generally, we can discuss the results as consequentially to use to predict the possible cooling of production boreholes due to long-term re-inaction. And in complex system, the tracer testing has a comparable purpose, even though it's rather aimed to evaluating the energy extraction efficiently and the longevity. So is also a prediction logging to evaluate the well's longevity and the lifetime of operation between the cycle of re-inaction and inaction in borehole. It's a fundamental real types of new logs. We have some curve that you extract from recent work, the graph showing you the temperature that it depends from the half-life of several naphthalene sulfoten trace. In this case we are using a chemical reaction to make the tracer. The temperature dependence on fluorescein and rhodamine are shown for comparison. We can also analyze the type of phase that they are present in wells. For example, if we have one or two physical phase or three physical phase, when we have, for example, steam and water, water streamer and other gas condensate, that is another case. Is really important to study the hydrodynamic condition of wells and to check the stability and the security and other else. Instead of this, we can also say that that we can evaluate it, that we can do extract some quantitative parameters like the breakthrough curve characteristic, that is a quantitative parameters that represents the interconnectivity of all joint fracture activity. We can use the quantitative connectivity index that is called CI. In this case, it represents how many fractures are connected between the activity steam reservoir. So another important quantitative parameter is the effective contact volume, SCV. The tracer duration reflects the size of the simulated region. So the basic formula is that where mass or tracer injected, the peak produced, concentration, and other else. There is the D is dispersion, V the velocity, and X the path length. So this is the base place. This is another quantitative parameters. Generally, how long we can build up this test? We have from 20 to 48 hours. And we have some estimated the effect volume. For example, another quantitative parameter is estimated effect volume, and also with this kind of formula, advanced model transport equation fit, use advanced dispersion modeling, and we can estimate also the fracture, the main fracture direction. So if you are evaluated, for example, 100, 200 fraction, you can evaluate the main direction of fracture with this kind of logs, because you can put in them the tracer, chemical tracer or radiative tracer, and you estimated the main fracture direction. So for multiple well tracer, we have a fun test, the inaction tracer monitoring we can monitoring in the same time from 3 to 5 observation well. So the well that receive tracers have the following characteristic. For the first, fracture direction is aligned with the well. The highest concentration means that we have a measured conductivity fracture. For multiple wells, when you have multiple wells to testing in the same time, so the fracture nectar or branching system. You need to establish a fracture network or branching system. The third method is the DTS plus thermal tracer, cold slang injection. When you want to test the temperature and analyze the steam part and the water part, you need to do the DTS show cooling streaks, fracture orientation in the detailed wells. Application, it's clear that we have summarized several applications in geothermal simulation. The first important application is evaluate the possibility of stimulated wells, increasing, for example, hydraulic connectivity. So it's clear if you have a clear mapping of joint fracture, activity fracture, non-activity fracture, connective fracture that are connected, you can make an increase, you can planning an increase of connectivity after hydraulic stimulation. Activity fracture and show faster breakouts. Identify conductivity versus non-conductivity fracture helps decide whether additional stimulation is needed. The third application is compute sweep efficiency for reinjection wells. It's clear that generally the main geothermal plants have extraction wells and reinjection wells that we can commute steams, not use steams in water and the reinjection in wells. So we can ensure the injected waters flow back into the reservoir and not from the out zone of that. So you can control all process, for example, of injection wells. The consequence of that is that we can map the fracture orientation and growth. The touch anisotropic created during stimulation. We can validating the modeling with microseismic image and image logs. Finally, we can design multiple stage simulation program. We can prioritize zone which need, for example, an stimulation with high contact volume. You can, when you have all mapped the fracture and or fracture that are connected, you can extract the contact, as we just said, we call the contact volume. So the volume of all fracture are connected and the volume of fracture that are not connected. So you need to concentrate, for example, for the volume of fracture that are not connected and make a specific stimulation of this. It's clear that is a precious intervention and a specified intervention that only the company can do. Derivable products from trace log test, connectivity map, fracture flow direction, effective reservoir volume, flow contribution for fracture, trace derivation, residence time curves. So we have around 6 or 7 derivable products from trace log. The first important is like the connectivity map, is that it represents the all joint fractures are connected. The fracture flow direction is much more important to study. Also the flow from the fracture are connected, and which is the main direction from hydraulic point of view. Effective reservoir volume or fracture that are connected constitute the volume connected, the flow contribution by fracture, the tracer dilution and resident time curves. That is another important parameters. With recommendation for further stimulation and other production strategy. We can implement these in all proprietary software like TechLog or Petrel. All data we can process it, and so like this. So finally we have the curve, we have some plotting curve or residence time curve. The residence time curve is very important because representing the time in which, for example, chemical reaction, chemical tracer or quantitative tracer remain in the fracture. So if you have an estimation of resident time, you can estimate it how is the velocity of the flux or the flux water and steam we have in single type of fracture. Is very important parameters because you can underline the velocity, you can estimate also the pressure of steam flows, for example, steams of water flows between the fracture, and is very important for the production.